by the encoder into encoded values which don't affect the XML schema. Seems like a good way to prevent my XML attacks. But that's not the only thing people use encoding for. Encoding output is also used to prevent cross-site scripting. So if somebody submits some script, the end user's browser doesn't render it as HTML and execute the script, but rather just represents a visual version of it. The problem is these encodings don't substitute for each other. And I have seen cases where developers think, well, I'm using encoding, and therefore I'm safe. But the encoding you're doing for storage is completely different from the encoding you're doing for user display. There are different layers. And the encoding you do on data storage is reversed before the data is output. So the problem you can run into is things like this, where I've got an encoder that's stripping out angle brackets and that sort of thing, but not worrying about other values. And so I've stored in my database an encoded cross-site scripting attack. Now, when it goes to display to the user, well, it pulls it out of the database, it reverses the encoding. Encoding it never did, because the attacker did that encoding, and essentially weaponizes the data in the database. So just when using encoding, it's important to be careful to remember what encoding you're doing and make sure that you reverse what you do and not what other people are doing. So I'm going to switch gears a bit to a different use of cloud storage and the vulnerabilities that can introduce. Not all attacks on cloud storage involve application bugs. One thing that people use cloud storage for is storing public or semi-public files for end-user download. It's a natural fit for cloud storage. There's massive storage capacity and cheap, scalable bandwidth. If I want to host, say, video or audio content for my end users to download, I'd love to be able to put it in my cheap, scalable cloud storage and allow my users to download directly from that store. The problem is that when you have a subscription-based site, you can run into some difficulties with this. The files, after all, are hosted on the cloud provider. They're not hosted on your web server. They're not part of your application. They're not behind your application's access control. You may have an htaccess file or various cookie-based authentication and so on your app, but once somebody actually clicks on the file in cloud storage, they're getting redirected over to the cloud storage engine itself and pulling the file down from there. So that's not behind your access control. What sites often do with subscription sites, I've mainly seen this with sites that are selling ebooks and instructional videos and various informational content. It's very popular for affiliate marketing businesses and so on to sell information products this way and host them in cloud storage. So what they often do is they resort to security by obscurity. They put all of their files on the cloud storage engine, and then they give their containers or buckets a really long hexadecimal name or just a name they don't publish out to the users, and they hope nobody will find it. And then they only put the links inside their own site behind the access control. This is also a problem when it comes to sites with tiered access levels. What enumeration is I've got all this in cloud storage. If I get one of those URLs, I now have at least that file name or the container name, and I can connect to the cloud storage system itself and download the file or even ask it what's in the container and get all the other files as well without necessarily going through the site access control. It's not just sites that are subscription-based that run into this, but also sites that are multi-tenant or have tiered access control. Because if I'm storing everything in the same back-end bucket, once somebody has the URL for one of my files, they can then enumerate it to get the URL for other files. So I'm just going to give a quick demonstration of how easy this is. So this, you probably can't read it due to the size, but this is an easily available on the internet tool called S3 Ripper. And it's a simple matter of You go onto a website that's using cloud storage, you hit view source and see what all their cloud storage URLs show. A lot of times the subscription-based content that's behind the access control and the images and style sheets on the homepage are in the same bucket. So the bucket name's right there in the source on the homepage. And you type in the bucket name and click Find Files and Folders. And I'm not connected to the network. Okay, live demos never work. I should know better than to try to do that. In any case, it will list every file in the entire container along with the file type, date, file size, and you can download any of them or even click a download files and it will promptly download everything in the entire container to your computer, thus duplicating everything that they have on their server in their cloud storage. So the problem here is that the use of public buckets in an access-controlled or multi-tenancy situation is inappropriate. Not only do you have the problem of people may get it from the source of your website, but you also have the problem of one person buys your product with a subscription and then they go and publish the URL on a public forum somewhere. And now no one else has to buy your subscription. They can just grab the URL, paste it into a tool, download all of it at once. In addition, members of one tenant or access control level may be able to access the files in another one. There are a variety of ineffective mitigations I've seen people try to use in order to serve subscription-based content out of cloud storage. There are varying kinds of security by obscurity. There's the giving them long, complicated names and hope people won't guess them. I've seen flash downloaders on a site with referrer checking. So in other words, instead of giving the user the link directly to the file, we serve up a flash app that downloads the file in the background and hands it to them. Well, this will stop your basic non-technical user from seeing the URL, but it doesn't solve the problem of posting on public forums once someone finds it. And if you just run a debugging proxy in HTTP, you can grab the URL straight off the wire when the flash app sends it. I've seen people register a separate domain CNAMEd to their AWS bucket, so their links go to some domain of theirs, and not to bucketname.s3.amazonaws.com. Once again, anybody who can just run dig or any domain tool can look at the DNS record and see what it maps to, and then post it on a public forum. It still doesn't work to keep things safe. The most ridiculous approach I've seen is provide a script on an access-controlled site that proxies the download. And they actually sell these scripts. You can pay a couple $100s to get one of these for your website, where you put a script on your website. So you give the user a link to download.php ? File name, and then on your web server, it uses curl to pull the file down and serve it up to the user. Well, it works. It does keep the file behind the access control, but you've given up all the advantages of cloud storage, because now instead of using the cheap bandwidth out of cloud storage, you've contrived a way to get to pay twice for the bandwidth, possibly 3 times, because your server is downloading it from the cloud provider, and the cloud provider is giving it to you, and then your user is downloading it from your service. So it's a great way to pay money for software that makes you pay more money for hosting. It doesn't really make a lot of sense. So how do we actually prevent enumeration? Well, one thing is container-level access control. In Windows Azure Storage, you can actually set a container property that says the blobs are public, but the container is not. This is why there aren't currently any enumeration tools like S3 Ripper out there for Windows Azure Storage. It wouldn't be terribly useful if the developers just set the storage policy to blob only. I'm not aware of any similar setting in Amazon S3. The thing about this, though, is it prevents enumeration, but not URL sharing of files. It means, okay, now someone can't grab one URL off my site and download all my files, but someone can still download all my files and then post the URLs to all of them on a public forum for someone to steal. So it's only a partial solution to the problem. The right solution is to use a private container and make use of Windows Azure Storage shared access signatures or Amazon S3 signed URLs to enforce the access control. This is only a mitigation and not a complete cure, but I'll talk a lot more about that in the defenses and mitigations section on how that can be used to make these sorts of data theft from subscription sites very difficult. So, in addition to writing secure applications, the storage itself has to be protected, because this brings back to the fact that if you're using cloud storage, your database backend is sitting on the internet. Anyone can make a TCP connection to it. It's only the cloud services access control that's keeping them out. So you have to protect the storage account itself. And both Amazon Web Services and Windows Azure use an email address and password as an administrative credential. On AWS, it's an Amazon account, and on Windows Azure, it's a Windows Live ID. In both of these cases, it's things which people use for other purposes. So never use the admin's normal Amazon account that they buy books for, or the Live ID account that they chat with their friends on MSNIM, as the credential for a cloud storage account. These should be treated like a domain admin or root password. This is a high-value credential. What's more, you want to make sure that the email account that's used is an email account where you have complete control of that domain. The problem with this is we have seen cases where entire enterprises have been compromised because someone was using as their central root administrator account a Hotmail or Gmail or other public webmail service. The webmail services that have a password reset, which tells you log in and answer 3 easy questions about me that you learned about on my Facebook, and you can reset my password to something else. And those password resets, when people are using a email address that's used for other purposes, can be used to reset that, gain control of the email address. Once you've gained control of the email address, you then reset your password with the cloud storage provider, and you've now taken control of the entire database layer for a company. Other than using a unique account that belongs to a domain you control, the other thing you can do is use multi-factor authentication where available. And I'll talk about the multi-factor authentication options for Amazon and Microsoft in a bit. So defenses and mitigations. There are a variety of things that you can do to defend your applications. There are the classics of input validation and encoding. If you're using the ASP.NET platform, there's Windows Communication Foundation data services. There are SOAP toolkits and WSDL-based code generation. Encryption plays some role here, although most of these are application-level attacks, and encryption's not going to do you a lot of good there. Multi-factor authentication, shared access signatures and signed URLs, and finally, proper application design and defense in depth. So input validation, all of these attacks come from malicious user input. So the first thing you can do is use available blacklist-based platform mitigations. So these are things like mod security if you're using Apache, or turning on validate request if you're using ASP.NET. Now, these are limited. They're blacklists. They're only going to stop the simplest attacks. It's possible for people to evade these in a variety of ways. In addition, you can't use them for everything. You can't use a simple blacklist like this if you actually take HTML input from your users. In addition, implement whitelist-based mitigations where it's possible, where you only allow data types that you expect. Whitelisting, once again, is better for some situations than others. It's really easy to write a whitelist for formatted data types. If you want a zip code or a social security number or a SHA hash, it's simple to write an input validator for that that's whitelist-based. If you're taking XML or HTML input, or if you're writing a Unicode global application where the same app needs to support 14 different languages, it can be a lot more difficult to come up with a whitelist that works and also still allows all the functionality to work right. When it comes to whitelist-based protection, Microsoft Web Protection Library has a set of encoders called anti-XSS, which are a good set of encoders that are well-researched. This is available as a .NET DLL. They're kept pretty up-to-date. It's a great thing to use if you happen to be writing an ASP.NET application. Once again, it's not a universal solution. Not everybody writes their apps in ASP.NET. Encoding is an attempt to render potentially malicious input or output harmless. There are a variety of ways you can try to do XML encoding versus a data storage attack. You could wrap user input in a C data block that will enclose the user input and prevent it from changing the schema. In that case, the only thing you have to filter out is the C data closing sequence, as 2 right brackets and a right angle bracket will end a C data block. XML and HTML encoding is actually